Okay guys, so today's lesson was very rushed, and I want to make sure that you are confident in how to do these last few questions so that the homework isn't so confusing for you. Now in each class we got to a different point in the lesson today, but I don't know if we were able to finish any of these except for maybe one class where we got to this one. So I'm going to do this example, I'm going to do this example, and I'm going to do this last one, or at least set it up for you, maybe not finish it. So let's start out with this example, and just to give you an idea where this is on your notes, if this is the whole back of your notes, this is the bottom left example. So we have to simplify this, which means at first that we need to identify that the operation taking place between these two fractions is actually multiplication. So there's a little invisible multiplication dot here. That's what's happening. And we remember from the front of our lesson that if we're multiplying, all we do is multiply our numerators and multiply our denominators. So when we do that, we're not going to do anything fancy. We're going to end up with a squared minus 9 times a squared plus a all over a squared minus 3a times a plus 3. That is not a brilliant move. We could all see that coming. Now it's the next step that's actually factoring these things that becomes a little bit more of a challenge. This a squared minus 9 is a quadratic. If we double bubble it, we can break it down into a plus 3 and a minus 3. And if you FOIL those, you'll see that that's true. With this quadratic here, we can't FOIL it, but you do see that we could factor here. Each of these terms has something in common. This term has 2 a's, this term has 1 a. So if I remove an a from this term, I will still have an a plus 1 inside of there. We can do a similar step with this a squared minus 3a. We can factor. Each term has an a. So we're going to pull that a outside, and we're going to be left with a minus 3. Now this a plus 3, we can't do anything with that. That's an a to the power of 1. We know that a binomial that looks like this is just a binomial factor. It's in its simplest form. So let's rewrite this fraction. Instead of it being like this, let's use these new factored forms. So we'll slide over here. This equals a plus 3 times a minus 3 times a plus 1. That's our numerator, fully factored. Our denominator then is a times a minus 3 times a plus 3. And now at this point, it's as simple as identifying the things that equal 1. A divided by a equals 1. A minus 3 divided by a minus 3 equals 1. And a plus 3 divided by a plus 3 equals 1. So what are we left over with? A plus 1. That's it. That example is not too bad. Let's move on to this example now. This operation taking place here, and if you were in the class where we did this example, skip on to the next problem. But this operation here is clearly not multiplication, that is division. When we divide, we can do something called keep, change, flip, which means to keep this fraction the same, change this sign to multiplication, and then flip this fraction. But that's the same as what we call multiplying by the reciprocal, and that's the math way of saying keep, change, flip. So let's do that. I'm going to rewrite this over here as x squared minus 16 over x squared minus x minus 20. I'm going to change the sign to multiplication, and I'm going to flip the second fraction, which is x plus 4, now over x minus 4. Remember that that used to be x minus 4 over x plus 4, but when we flip, it becomes this. At this point, it's just a multiplication problem. So let's push these things together. Now what we're looking at is x squared minus 16 times x plus 4 over x squared minus x minus 20 times x minus 4. And the last thing we have to do is just break these things down as much as we can. This term here is not as factored as it could be. This one, can't do anything to it. It's a binomial factor in its simplest form. This one is also a binomial factor in its simplest form. However, this is a quadratic that we can definitely factor. So when we factor those two things, we're going to end up with an equivalent fraction that is x plus 4 times x minus 4, again times x plus 4. Because this x plus 4 is still along for the ride. In our denominator, we'll have x minus 5 times x plus 4 times x minus 4. Now, we're pretty savvy with how to factor things now. We've been doing prime factorization for a while. So I'm going to rewrite this numerator as x plus 4 squared times x minus 4. Because we have two of those. We got one here, we got one here. So we can condense it and write it like this. And our denominator is not going to change. We still have our x minus 5, x plus 4, and x minus 4. All right, now we're just canceling things that equal 1. X minus 4 divided by x minus 4 equals 1. X plus 4, or one of them, divided by x plus 4 equals 1. We will still be left with an x plus 4 to the first power. So our answer here is x plus 4 over x minus 5. And that is as simple as we can make it. Remember, the point of this whole thing is getting one very simple rational expression. One fraction. All right, lastly, I'm not going to solve this last question because this video is getting kind of long, but I am going to help you set it up. It says the length of a rectangular patio is represented by this crazy expression right here. And its width is represented by this crazy expression. Determine the area of the garden in simplest form. Now this is right from a Common Core prep question, so it is exactly the kind of question you might see on a Common Core exam. Let's talk about what a rectangular patio would look like. From an overhead view, we might have something like this. Here's your patio. And we know that it has two measurements. The length of the patio is x squared plus 2x over x squared plus 2x minus 15. And the width of that patio is 2x minus 6 over 2x plus 4. Now, it doesn't really matter what we call those measurements because we know that area is just length times width. So now that we know what our length is and we know what our width is, we can just replace these things and multiply them, just like we've been doing with all the other examples. The word problem is just a tricky way of getting you to make sure you set up this problem as a multiplication of two rational expressions. All right, and you guys can finish that on your own. So good luck with the homework. I will post a homework video as well doing a couple of those examples. But I hope that you check this out and try to get an understanding of how this works. All right, so good luck, you guys. I'll see you tomorrow.